Okay, so on to unit 1.5, yeah, 1.5 I think. So unit 1.5 is all about solving equations. The first equation that we're going to solve is a linear equation, right? Because we only have the first degree of x, so it's a linear equation. So to solve this, we need to get all our x's together and all our constants on the other side. So I think the first thing to do, there's a lot of ways to do it, but the first way I would do it is I would subtract my 3x from both sides, minus 3x. So I'll get 4x minus 4 equals 8. And now this looks like a linear equation that we solved about 1,000,000 times. So add 4, I'll get 4x equals 12, divide by 4, I get x equals 3. So that's something that we've done literally 1,000,000 times by now. So the next thing that we're going to do is called solving literal equations, and that involves using equations that don't have numbers, or sometimes they have numbers, but have all sorts of variables in them, and we're solving them for a particular variable, and it comes in handy when you're doing science, like chemistry or physics. That's something you'll do a lot then, and it's also something you need to do in pre-calc. So for this example, we are solving for capital M. So I'm just going to put a box around it so I know that that's what I'm solving for. Okay, so the first thing I see, there's a lot of ways to do this as well. So the first thing I see is that I have an r squared on the bottom. So I want to get rid of divided by r squared. The way to get rid of a divided by r squared is multiply by r squared. If I multiply by r squared on one side, I have to multiply by r squared on the other side. So I get r squared times f equals g little m big M. And I'm still solving for big M. And so now I have big M is multiplied by g and little m. So I can just get rid of those, right? And they're multiplied, so to get rid of them, I'll divide by g little m, divide by g little m. So I'll get big M equals r squared f over big G little m. And so this is an equation that you'll see a lot in physics, actually. It's has to do with gravity, but that's neither here nor there. Okay, so the next one we see is another little equation, but now what we're doing is we're solving for W. And so we have a W here and a W here. So what I see is this term doesn't have a W, so I'm just going to move it. So I'll subtract 2LH minus 2LH from both sides. So I get big A minus 2LH equals 2LW plus 2WH. Okay, and I want to solve for W, so that's why I have all my terms with W together. So the next thing I need to do is I need to factor out a W from both of these terms. So I have my W, and then what's left in this term is my 2L, plus what's left in this term is my 2H. And that's why we learned about factoring out a common term last chapter. So well, that's one of the reasons. 2LH. Okay, and now, so I have W is multiplied by all of this. So let's just divide by all of that. 2L plus 2H divided by 2L plus 2H. And so I'll get W equals A minus 2LH over 2L plus 2H. And now remember, this, we can't just cross out, oh, I got a 2 and an H, I can't just cross those out. Remember, we can't cross those out unless they're factors. And they're not just plain factors all by themselves, so I can't cross those out. The next equation we're doing is a quadratic, right? I have x squared. Okay, and so we're solving this quadratic. We're not just factoring it. We have an equal sign here, so we're solving it. When there's no equal sign, you can't solve. That's the biggest pet peeve of mine, is when people have something that just looks like this, and they try to solve it. you can't solve it. You can't get an answer. You can just factor it. So if we have that x squared plus 5x equals 24, so to solve quadratics, I know that if I have an x term, I always need to get everything onto one side and get my equation equal to 0. I'll tell you why I said that in a minute, but so we have my x squared plus 5x minus 24 equals 0. Okay, so now I have to factor this. What are factors of negative 24 that add up to positive 5? Well, they're 8 and negative 3. So I have x plus 8, x minus 3 equals 0. And the zero property product tells us that for two things to multiply to 0, one or the other has to equal 0. So I know that x plus 8 could equal 0, or I know that x minus 3 could equal 0. So I know that x equals negative 8, just by subtracting 8 from both sides, or x equals 3. And those are my two answers, x equals negative 8 and x equals 3. Okay, my next two examples are quadratics that don't have just an x term. We've done these a lot already this year. You do the square root method. So if I take the square root of this side and the square root of that side, but remember, whenever I take the square root, I have to do plus or minus. So my answer, the square roots will cancel out, so I get x equals plus or minus the square root of 5. And that's how I can leave it. I can leave it like that. I don't want to get, my decimal approximation of 2 point whatever it is, because square root of 5 is an exact number, and square root of 5 is an exact number, and my 2 point whatever is just some estimation. Okay, so this one, there are easy ways and hard ways that I can do this one. The hard way is factoring it out, expanding it out, moving the 5 over, seeing if I can factor. If not, I'll have to do the quadratic formula, which we'll talk about in about a minute. But the easy way is I just have this thing squared equals this. So if that thing squared equals this, I can just take the square root of that side and take the square root of that side. But remember, when I take the square root, I have to do plus or minus. So now I get x minus 4, right, because the square roots cancel out, square and square root cancels out, equals plus or minus the square root of 5. And now I need to get x all by itself, so I need to add 4 to both sides. Plus 4, plus 4. So I get x equals, I can't add these together, so I have to do 4 plus or minus the square root of 5. Okay? And remember, whenever we have quadratics, we have two answers. We have up to 2 answers. And so those are my two answers, 4 plus the square root of 5 and 4 minus the square root of 5. I'm going to skip, for now, the completing the square method, because I'm going to do a whole 15-minute video on that, completing the square method, because that one's really important. And it's a little tricky at first, but it gets to be so easy that you'll want to do it all the time. It's my favorite method, and I use it all the time. But for now, we're going to do the quadratic formula, which is something we've done before, right? So we do b squared. No. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember that story that Miss M told us? Xavier was a negative boy who couldn't decide whether or not to be radical or be square. I don't remember the rest of the thing. Okay. But that's the quadratic formula. So we'll take that and use that for our next couple problems. So our first problem is 3x squared minus 5x minus 1 equals 0. And so I'll just plug this into my quadratic formula. So I have my 3 is my a value, my b is negative 5, and my c is negative 1. So I do negative b, so the opposite of b, the opposite of negative 5 is positive 5. Plus or minus the square root of 5 squared, negative 5 squared, minus 4 times 3 times 1 all over 2 times 3. So I'm going to pause and I'll simplify it, and then we'll get back together. Okay, so all I did was I did my negative 5 squared was 25. I did my 4 times 3 times 1. That's a negative 1, so that's a plus 12. See, I make mistakes. It's just important that you check your work. Divided by 2 times 3 is 6. So now if I simplify this a little bit more, I get 5 plus or minus the square root of 37 all over 6. And I can't take the square root of 37. Last time I checked, 37 was prime, so I can't simplify, and 5 doesn't go into 6, so I'm done. I can leave it like that. My next problem is 4x squared plus 12x plus 9. So if I have 4x squared plus 12x plus 9, I have my a value, my b value, and my c value. So I'm going to do my quadratic formula again. Negative 12 plus or minus the square root of 12 squared minus 4 times 9 all over 2 times 4. So I'll take a pause and simplify and come back. Okay, so I get 12 squared is 144, 4 times 9 is also 144, and 2 times 4 is 8. So now if I simplify this, I get negative 12 plus or minus the square root of 0 all over 8. Square root of 0 is just 0, so let's just cross that out. So I get negative 12 over 8. So negative 12 over 8 simplifies to what? Negative 3/4. And so this is one of the times where a quadratic only has one solution. And so what that means is that if we were to graph this quadratic, if we were to graph it, it would just come and touch the graph right at there 3/4, and that would be the only time it would touch it. And that's what we're doing when we're solving quadratics. We're finding the x-intercepts. And so our last quadratic that we're going to do is x squared plus 2x plus 2. So we have our a value is the 1 that's here, our b value is 2, and our c value is 2. So it's really important that your a value is 1. You have to remember that there is a secret 1 hiding there. So if I plug this in, I'll get negative 2 plus or minus the square root of 2 squared minus 4 times 1 times 2 all over 2 times 1. Okay, I'm going to pause. So I get that I have negative 2 plus or minus the square root of 4 minus 8 over 2. But when I do this, 4 minus 8, so negative 2 plus or minus the square root of negative 4 all over 2. So what I notice is that I see that this is going to be an imaginary answer. So I will have no real solutions. Okay, and we could have found that out by when we look at our quadratic formula again. If you remember, this part right here. Well, it's really the stuff inside the square root is called the discriminant. So we know that b squared minus 4ac. We know that there are 3 cases. We know that it could be greater than 0, it could be equal to 0, or it could be less than 0. If it's greater than 0, there are 2 real solutions. If it's equal to 0, there's 1 real solution. And if it's less than 0, there are no real solutions. Okay, that's all the time we have for right now. The next video is going to go back and do the completing the square method, which is very important, and it's actually how we get the quadratic formula. So maybe if I have time, I'll actually show that in the completing the square video. But for now, I will see you back in the next video.